Hello everyone, my name is Ashfaq Ahmed and today we are live from YouTube channel Bioinformatics Insights. I'm here to address your questions, to discuss your questions, or to guide you or to give you some suggestions. So if you are here, so far I can see some of the people have connected. So you can ask your questions, you can ask your queries, and I will try my best to answer each and every of your query. Thank you. But one thing, when you are going to message me, so it's better to introduce yourself, at least your name, so that I can use your name while addressing your question. Thank you. So I received the first question, and it's from Abu Bakr. He is asking that by learning molecular docking in Google Colab or by Autodoc Vina or maybe some other software or by pharmacophore modeling and either by learning from this channel using playlist up screening, if we work on antibiotic resistance, is it a good idea? Of course, it is a good idea. I have personally worked in my postdoc on antibiotic resistance, but my work was combined by in vitro and in silico. So there are so many antibiotic resistant genes. I'm not sure in particular which gene you are interested, but it doesn't matter which protein you are working. If it is antibiotic resistance and you want to design inhibitors, so you can. Also, I will suggest you some extra things. There is one video in the channel, and its name is Molecular Property Analysis in Real Time. Uh, and it's, if I'm not mistaken, it is almost 10 to 12 minutes, not a longer video. So you can use that video extensively, and once you find your top inhibitors, you can edit, you can bring some minor modification in those inhibitor and redock it to make it more bitter. for your active pocket. So I know it will be a trial and error method, but if you can find a potential or you can generate a potentially good compound. So it doesn't matter whether you learn from my playlist or whether you learn from someone else or from some books or some other video, until and unless if you know how to perform docking and what are the pros and cons of docking. Because many people perform docking, just take compounds, take uh, receptor molecules and perform docking, and that's it. So I do not uh, normally suggest people to perform such kinds of docking. You must have a real knowledge that why you are doing certain steps, why you are skipping certain steps, etc., etc. So the conclusion is yes, you can you can utilize docking strategies on antibiotic resistance. Okay, so far we have almost 6 to 7 people. So believe me, I was not expecting this much uh, because normally I come online without announcement. Today I announce, but so far uh, not so many people. Walaikum assalam. Miss Kainat Tufel. She is my student. So, Kainat, you can ask a question if you have any. So, I was not expecting that people will come, but at least I'm happy. I have 4 to 5 people, so I can address their issues. I can talk about on their research topics if they have some problem, so you can discuss. Exclusive media, walaikum assalam. That's good, you are also here. Stay tuned. Okay, I'm asking one thing. Are you people are seeing the comments? आपको जो कमेंट्स मुझे आ रहे हैं ये आप लोगों को नजर आ रहे हैं या नहीं जो आपके मैसेजेस आ रहे हैं? Okay, that's good. You are seeing the comments. So it means I cannot skip any question if you ask. Okay, so far I have 4 people right now, and in these four, 3 are my students, and one is Mr. Abu Bakr. So I know my student; they may not ask any question. So Abu Bakr, if you have any other question, you can ask. Don't wait for other people. Hello, Goodwill. Anthony. I will call you Anthony. Uh, you know why I'm smiling? Because you or your friend have asked me for DFT, and then I answered in the comment section that it will take time. Then maybe one of your friend or your countrymate asked me again, and then I asked the same. Now your question again is the same here that can I make a density function theory? So, okay, I promise I will make a series of video on density function theory, but we have some festival coming next week, so probably after a week, okay? Because I know if I do not make video on density functional theory, so you will not forgive me. You will come and will ask me everywhere. Just a joke. But the point is why I'm reluctant on density functional theory. Uh, I think nobody is interested in this topic, but leave it. I will not talk for other people. I will not think of other people. I will only think of you and will make one, two, or three, how many I can. I will make it. So wait for at least a week or maybe two, but I will try to be not make it so long for week or two. So just give me 7 or 8 days to come back to a normal routine. Okay, if you have any question, Anthony, you can ask. Thanks, Anthony. Thanks you are watching or you are liking my videos or you are liking the way I teach. So I will try my best. But the reality, most of the people don't like this kind of stuff where where I make or someone else make more than 10 to 20 minutes a video. So I know for some of the people it will be a bit harder to digest, but I will keep working in the same fashion just to make longer video. For a bioinformatics only learning dry lab is enough, or if we want to learn wet lab, will it waste of time or we should learn if we want? Shazma Sarwat, Assalamu alaikum. Wa alaikum salam, Shazma. Um, okay. So if you have any question, you can ask. Abu Bakr, I will come to your question that for bioinformatics, wet lab is necessary or is it a waste of time? Of course, if you have the opportunity to learn a wet lab, you have to learn. Here I want to disclose something in front of you people. If you are liking my videos or if you are liking my lecture, so there is one thing that is helping me, and that is that I did not learn bioinformatics initially. I'm basically a structural biologist initially. I have 28 structure in PDB solved by X-ray crystallography, and later on, it was a need in my lab when I was doing a PhD that they have asked me or somehow they have compelled me to learn bioinformatics. And from there, I started to learn bioinformatics. So And so that wet lab part, which I worked on in a PhD, is really helping me. So many people will teach you about protein sciences or proteomics or docking or all these steps, but maybe I just feel that they are lacking. So I have what edge I have, the edge I have that I actually understand the protein structure. I understand it, the protein structure first through X-ray crystallography. Then I came to bioinformatics and proteomics. So what I believe, if you have time, if you have opportunity, go for wet lab. This is must. If you have the wet lab experience, now combine it with the bioinformatics, you will be someone else. But if you have only bioinformatics, so of course you will be a better guy, but at times you will lack. So the answer is that if you have opportunity, if you have time, just go for it. Don't wait. It is not a waste of time. Okay, walaikum assalam, Shazma. If you have any question, you can ask, or if you want to participate, or if you want just to listen, hear the live discussion. So you are more than welcome to listen or to be a participant. Is it feasible to employ distinct virtual screening strategies for a single protein that possesses separate binding domains, specifically the ATP binding domain and the allosteric domain? I got it. Okay. Your question is it feasible to employ distinct virtual screening strategies for a single protein? So let me first break down your question into pieces. Probably you are working on some kind of receptor. I would say you are working on GPCR receptors or any other receptor which has a catalytic domain. Normally, the receptor are the transporters. Normally, the transporter have the catalytic domain, which provides energy, and those catalytic domains use ATP. So either you are working on a transporter, or either you are working on some GPCR receptor, because the GPCR receptor contains two things, or also some proteins, I would say, uh, they contains allosteric binding site, and they contains the another binding site for a ligand. Your question is that is it feasible to imply distinct virtual screening strategies for a single protein? Okay. If so, what approach would be most suitable for the ATP binding domain, and which would be optimal for allosteric domain? Shazma, first of all, you have to decide which region in primary, or mainly which region you want to restrict. You want to restrict the allosteric region, or you want to restrict the actual binding pocket. This is option one. You must have some priority, because allostery is deal with the conformational changes. It means if you are blocking the allostery, so it means you are trying to restrict the conformational changes of the protein. For example, this is your protein. So this is the if this is the active pocket, and this is the allosteric pocket. So if the protein moves this way or this way, so this kind of motion is controlled by this region. This is the allosteric region. So now if you keep something here, now the protein will not come like this because something is here. So it means in this case you have blocked the allosteric region. The second thing is you have to block if you want to block the ac- actual active pocket. So, first of all, you need to decide which area you want to target. After that, you can go for normal docking strategies. We have already covered some 7 or 8 lectures. You can watch them, or it's not necessary that only you can watch my stuff. You can watch some other stuff from anywhere else. So you can design different strategies. One is the pharmacophore strategy, one is the direct structural based strategy. So it is up to you to go for a structural based screening or the pharmacophore based screening. But if you want to combine both of them, it is also possible. Just make some pharmacophore and then filter out your structure based on the pharmacophore. This is part one. Now, in part two, just dog also the filter out compound which you excluded in part one and dog them again. In part three, you can calculate the properties of all these compounds. I have a video of 12 minutes, like checking the toxicity or the properties of compounds in real time. This is the video title. You can watch it, and from that video, you can learn in 12 minutes that how you can watch or how you can calculate the properties. So now, if you have top let's say if you have 1000 compound and you select the top 50 from them, either by pharmacophore or structural base. Now, in these top 50, some of them will be toxic, some of them will be mutagenic, some of them will have another issue. Remove them, exclude them. Now, you will have some top binders, and you can you can report those top binders, or you can, for further improvement, you can edit. I'm using the word edit to make it new molecules. And you will also learn in that video, in that 12 minutes video, how to edit compounds. It will give you a fair idea. And to the edited compounds, we normally call it derivatives. So you can generate derivatives and then report those derivatives. And even if you don't want to edit, you can uh, bring those compounds to the molecular dynamic simulation if you want, and then it will tell you whether they are the docking is really successful or not. It was a false positive result, because normally when we have some top compounds, then we become very happy that wow, we found some top compounds. But when we bring them to the docking studies, sorry, the simulation studies, so in simulation study we normally see that no, they are not as much good as we were expecting. So to the molecular dynamic simulation, personally, I repeat the word personally, I call it validation of the docking. So if you want to validate your docking result, you must go for molecular dynamics simulation. I hope I have answered some part of your question, although I have tried to cover each and everything. So still, if something is missing, you can ask me again. And nobody can tell you exactly that what approach you need to use, because all these approaches are perfect in a sense that you can use it. If you are asking what you need to target, allosteric or the normal pocket, I would suggest if you are searching for the easy option, so go for the normal topic, the normal pocket, because the allosteric is not that much easy to target. Okay, thank you. You are welcome. So, if I'm not wrong, everyone has got their answer possibly, and they are disconnected. So that's fine. I'm here for some more time. If they came, then I will address. Otherwise, this session, we will wind up this session. Shazma, may I ask you which protein you are dealing? I have one more question. Sure, you can ask. There is no limitation on your questions as far as I'm here. You can ask. Okay, your answer is, can you explain how AI algorithms can improve the efficiency and accuracy of virtual screening in drug discovery? Uh, I want to explain in a minute differences. There are different things. One is the basic name is AI, artificial intelligence. Then the artificial intelligence can be grouped into two parts. To the one we call it deep learning, and to the other we call it machine learning. In deep learning, then it comes neural networks, etc. And in machine learning is pretty much straightforward as compared to the deep learning. So normally, most of the people are using machine learning, that branch of AI, in drug discovery. Now the question is how they can improve the virtual screening in drug discovery. So for that, first you need to understand what machine learning is. The most simplest way, if I want to explain, it will be like this, that if I if you are a machine, okay, don't mind my example, but to make you understand, I will use such kind of examples. If I want to remember, let's say if you ask me to remember these 100 pictures or 1000 pictures, and I just quickly learn it, let's say picture of people, and then on every picture there is, let's say, some specific patterns of the scarf color and patterns of the eye color, and whether they have glasses or not in those picture, and also a name is written on every picture. So you gave me, let's say, 30 minutes, you gave me 100 pictures or 1000 picture, I quickly looked to them. Now after 30 minutes you asked me that, okay, what is the name of this guy? You hide the name, you show me the picture. I don't think so, I will answer. Okay. Now, possibly you ask me that, okay, who was the most handsome guy in this picture or girl in this picture? I may not answer you again. Now, you can also ask me, okay, there was 10 picture of girls. Can you tell me how many of them had a blue scarf or a black scarf? I may not answer you exactly again because I'm not a machine. So if you ask a machine, if you ask a computer, if you ask a model to remember all these big pictures, so the machine or the computer or the algorithm can do this job quickly and can answer all your questions quickly. Okay, so this was the simplest explanation of machine learning. Now, how it can help us in drug discovery. So, in drug discovery, you provide a drug, you provide the bigger data. Let's say you collect it from the chemical, you provide this data, let's say 1000, 2000, 3000 molecule to the algorithm. You ask them that, okay, remember these molecules are active, these molecules are inactive based on the IC50 or the PIC50. Okay. Now you ask the machine or the computer that remember it. The machine or the computer or the algorithm will remember for these 4000 how many of them are active, how many of them are inactive based on the PIC50. Now you ask them, remember the structure. Okay, to those structure we call it fingerprints. So you actually ask them, remember the fingerprints of each structure in each category. From the category, I mean active, inactive, or maybe intermediate like this. Okay, now the machine or the algorithm is going to remember all these stuff. Now, finally, your machine is ready. Machine is remembering all the active structure, the machine has remembered all the functional groups or the structural fragments, I would say, or the fingerprints, I would say. The machine is also remembering this information. Now you have 10 new molecules, 10, 20, 30, 40, 1, but I just use a 10 word. Okay, you have new molecules 10. Now you provide that structure, the new molecule structure to the computer that, okay, tell me what will be the fate, what will be the prediction, what will be the behavior of this molecule. So the machine will look to the fingerprints of the active, then will compare to this new structure and will tell you that, okay, it may have the PIC5013 and it will be active. It may have the PIC50 value 2 and it will be inactive. So what it helps you, it helps you like nowadays we are going to screen or to perform virtual screening for thousands of molecules. So if we introduce AI or machine learning in the drug discovery, so we will perform first the ML, and we will check all our 1000 or 2000 molecule on the ML. If the email tells us that okay, these hundreds are active, these 900s are inactive, so we will not waste further time on those 900 molecules. We will carry only those 100 molecules to the virtual screening. So this is a kind of filtration that we have used machine learning, and we filtered our data set for next step. I hope I have answered my question. Still, if you have any problem or any confusion, please ask. I have a few other guys online, so if you have any question, don't wait. Just ask in comment section. I will reply to you once I finish the previous question. Okay, that's good. You got my point, but the why I'm using this kind of example, my students in the university, they know me very well. I normally use such kind of ready-made example or spontaneous examples because it is the only way you can capture or you can take the interest of other people. So machine learning is not a very hard task. It's easy, and I'm planning to come to the machine learning in the near future. So let's wait. If you don't know about machine learning, so I will try to cover a series of videos or how to perform machine learning, particularly in drug discovery. Okay, inshallah, we'll cover it. There are some more guys online, and I cannot see them. Probably they are not subscribers, so that is fine. But if you have any question, you can ask. Because I'm not doing this session just to grab my subscribers. Uh, I have left the subscriber part alone. Um, if anyone likes, they can subscribe. If you are not um, well, or if you are not okay with subscription, so that is fine. I kept a notebook here on my left side, and on my right is another computer, and I was thinking for so many questions. Maybe I was also thinking that maybe there could be very strange questions, and so I have to note it down. But one thing I was actually also I was aware that people may not be so interested to participate in this kind of session. So still, I was right because the most people I got were six. Chasma, can you tell me which protein you are working? If you have no problem, so you can tell me. Otherwise, if you don't want, so then don't tell me. Just give me some time. Okay, so I have to sign off or sign out because I don't have any other guy. So it's not a good idea just to keep the session on without some real people, real students, or real humans. Okay, so Stay happy, be happy wherever you are, and bye bye.